Encrusting corals grow by adding polyps to the edges of the colony, and the colony itself simply forms a flat crust that has the same shape as the underlying reef. We see our initial baby coral glued down to the reef substratum, and over time new polyps are added to the edges of the colony. The polyps simply form a flat crust that has the same shape as the underlying reef. Now let's look at some skeletons of encrusting corals. Because of the way these corals grow, it's actually quite difficult to get good specimens of them. But here you can see the coral skeleton forming a thin film over the substratum. If we turn the coral over, on the other side we can see the reef substratum here, and the coral skeleton forming a crust over the reef substratum. Foliose corals also grow by adding polyps to the edges of the colony, but for these foliose corals, only the central polyps are actually attached to the underlying reef. Again, we start off with a single coral polyp. Over time, new polyps are added to the edges of the colony, but you can see only the central polyps are attached to the underlying reef. In this case, the coral colony is growing outwards from a central point, and only that central point is attached to the reef. Here are some skeletons of foliose corals. You can see that foliose corals can have very different corallite shapes and sizes. In this one example, the corallites are approximately 1 centimeter in diameter, and you can see that they poke out from the colony surface. The walls are separate, and you can see skeletal features, in this case the costae, running along the outside of the corallite. You can also see the septa running down the inside of the corallite. For this specimen, this area here would be the base of attachment to the reef, and you can see the plates or folds of the colonies growing outwards from that central point. Overall, the colony forms a thin plate that's only attached to the reef at that central point. Now here's another example of a foliose coral. In this coral, the corallites are substantially smaller, so they're only about 0.5 centimeter in diameter. And you can see that they don't actually poke out very far from the skeleton surface. Instead, the corallites are like small holes or pits in the surface. This species has what we call septocostae, and you might remember that these are elements of skeleton that run between adjacent corallites. This one coral was quite a large plate when it was collected, and the base of attachment would have been over on the left-hand side. The underside of the colony in this case has been covered with barnacles, so you can see that this plate of the colony wasn't actually attached to the underlying reef substratum.